Dan Perry here with another Dan on Tech Python video. Alright, let's continue where we were in the last one. So let me duplicate this one and call it 003. And this one we're going to do some similar things. We've still got those variables we had before. Remember we said, although I'm calling them variables, integers, floats, strings, those are immutable objects. They don't actually change. However, when I redefine those identifier names, it creates a new value. So it does look like it does change those like they do in other languages, but they are immutable data types. And we had the Z there. I'm going to copy these two lines. Now paste them. And I'm going to say X divided by Y. Let's go ahead and run this one. Now, it's showing still program 2 up here in the run, and if I do the drop down, I don't see program 3 yet. And the reason I don't see it is I would have to either edit the configuration, or the first time I run it, I can come over here, right-click on that file, and click Run. And now it will appear up here in the upper right-hand corner, and now it showed that X and Y have not changed, but Z is now 0.6. So when we did that before, Z was a type of integer. Now Z, this new Z, is a type float. And if we want to see that, let me go ahead and add another print. And remember, we could see the type. We've looked at the type before, and of Z, if I would spell print correctly. And now let's copy that and come down here and paste it. And now let's run it again. Because we've ran program 3, it shows up here in our list now, and I run it, and it shows here it's a class int, and then when it's redefined, it is now a class float, because we did an integer, or I'm sorry, a regular division. I'm going to copy this again, all these. If you remember, we had the modulus, or remainder, and let's see what happens here. We've got 3 divided by 5, so that's going to be a fraction. So let's see what happens with the remainder this time. It says Z is 3. Well, 3 divided by 5 goes 0 times with a remainder of 3, so we can do the modulus version here. We now see how that works. All right, let's go and let's do one more thing with this one. I'm going to copy it again. And in this time, instead of doing the modulus, I'm going to do the double asterisk. And the double asterisk says raised to the power. So this will be 3 raised to the 5th power. And when I run it, I end up with 243. So 3 times 3 times 3 times 3 times 3. Now let's change Y. So I can change the value of Y. Make Y equal to 10. And let's run this. And now I get 5,000 or 59,049. So you can see we can raise things to a power. Let's go one step further, and because I do want to illustrate something. And I'm going to say this time, I'm going to say X equals 100. 100 raised to the 10th, and let me run this. And you see this very, very large number, and I'm not going to even try to count the number of zeros. In a lot of languages, integer values are limited. They're either maybe 32 bits, and that would limit them to somewhere around 4 billion. Maybe they're 64 bits, which is even bigger, but let's add this one, go and make y 100 and run it. And look at how many zeros I've got. What we have here is the ability of essentially almost unlimited sizes for integers. The way that Python works with integer values, you can have almost unlimited. They'll say, the documentation says unlimited size. I'm sure there's some point where we would not be able to do the integers, maybe due to just complex calculations and all. But integer sizes are essentially unlimited. When we look at floating point numbers, we're restricted to what the floating point sizes are, and we'll talk about that later. But you can see here in this program, we've now gotten to see how we can do math and work with even very large integer values. Thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss future videos. Please check out and subscribe to our other Dan on Tech channel playlists.